Isaac Newton was a scientist who lived from 1643 to 1727. He proposed 3 important laws that shaped the field of physics. They described the relationship between an object's motion and the force that acts upon it. To understand Newton's laws, we must first fundamentally understand what a force means in the context of physics. A force, simply put, is anything affecting the acceleration of an object. Acceleration refers to the change in velocity, which you can think of as speed. This means that acceleration affects how quickly something moves. Velocity and speed, however, are not the same things. Speed is just a single value describing the magnitude of how fast something is moving. Velocity, on the other hand, describes both the magnitude of how fast something is moving and the direction that it moves in. This means that velocity is known as a vector, which has both a magnitude and a direction. In a velocity vector, speed is the magnitude. Force is also expressed as a vector because it, like velocity, has a magnitude and direction. Now we can move on to Newton's first law, which states that an object's motion stays the same if there is no external force acting upon it. This means that objects at rest stay at rest unless there is something else applying external force on them. For example, you have to put effort into pushing a boulder because it will not move on its own. This also means that objects that have been sent into motion will stay in motion unless there is the presence of some other external force. For instance, you may notice that if you push off the edge of an ice skating rink, you glide along the ice even after the initial push is not acting on you. This is because anything in motion has a tendency to stay in motion. You may notice, however, that you eventually decelerate and stop moving. This is because there is an external force, friction, resulting from movement between you and the ice. Newton's second law states that the total or net force acting upon an object is equal to the object's mass multiplied by its acceleration. This means that if there are 2 equal forces acting upon an object in opposite directions, then there is no net force because the object has no acceleration, or no velocity. That is, the object is not moving. Newton's third law states that every reaction has an equal and opposite reaction. This means that when one object exerts a force onto another object, the other object exerts the same force back onto the first object, but acting in the opposite direction. To visualize this, let us imagine the ice skating rink again. When you push off the side of the ice rink, you move in the opposite direction of your push. This is because the side of the rink exerts a force on you, pushing you away from it. This force is a reaction to your initial push on the ice rink. The 3 laws of motion that I just described here are very important in many applications of physics. I hope you enjoyed learning about Newton's laws. Thank you for watching.